Mathematics at Init College, a YouTube channel for high school mathematics education. Mathematics 5, Swedish High School Education System. Hi, this is Babak. In this video I am going to solve the following problem for you. This is a problem on the topic of the sum of the terms of an arithmetic progression. Let me read the problem for you first. In an arithmetic progression, S sub m is equal to n and S sub n is equal to m for distinct natural numbers m and n. What is the simplest possible form of m plus n plus S sub m plus n? Here, of course, you know that S sub m denotes the sum of the number of terms, the sum of the terms from the first term to the mth term of this arithmetic progression. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. The correct answer that you will get at the end is 0. Okay, now let me start solving the problem for you. I will try to solve this problem into two different ways. One way is just, I would call it natural way. Here you see that I have been given two pieces of information about this arithmetic progression. And usually if you want to specify any arithmetic progressions, you need two parameters, the first term and the common difference, because if the first term and the common difference are given to you, you add the common difference to the first term, you get the second term. Now that you have the second term, you add the common difference to the second term, you get the third term, and then you can continue so forth. Yes? So in principle, I need two pieces of information to specify my arithmetic progression. And if I have my arithmetic progression, in principle, I should be able to answer any questions regarding that arithmetic progression. So, and now you see that I have been provided with two pieces of information. So somehow I realize that I can use these two pieces of information to obtain the first term and the common difference. Okay, so let me start very naturally. Okay, so let me just remind you for the arithmetic progression, S sub k for any natural number k is equal to k over 2, and then you have 2 times the first term plus this index k minus 1 times the common difference. So this is the formula that we have for the sum of the first kth term of the arithmetic progression with first term a sub 1 and the common difference t. Okay, the first thing we are given is S sub m is equal to n. So if I replace k with m here, then I will have m over 2 times 2a1 plus plus m minus 1 times d is equal to n. Okay, and if I want to make it a little bit simpler, I will multiply this m over 2 here and there. Yes, so then it gives me these 2 and that 2 are gone, so it becomes ma1, and then I will have 1 over 2 m minus 1 d equals to n. Okay, and then I can similarly start with S sub n equals to m. Okay, and then of course I don't need to solve anything, because the only difference is that you see m has been replaced by n and n has been replaced by m. So what I will get at the end would be the same expression, and the difference is that m is replaced by n and n is replaced by m, so I don't need to spend time on it. Okay, so this becomes na1 plus 1 over 2 n times n minus 1 d equals to m. Okay, so here m and n are given natural numbers, but as you see, I have two unknowns, a1 and d. And how many equations do I have? I have two. So I have a system of two equations in two unknowns. Okay, so in principle, I can solve it parametrically and find my unknowns a1 and d in terms of m and n. Yes? So to do that, for example, I can multiply this by n. So I multiply n here in the first one, and I will multiply minus m here in the second one. Okay, so let us see how it goes. The first equation then becomes nm a1 plus 1 over 2 nm m minus 1 d equals to n squared. The second equation will be minus mn a1 minus 1 over 2 mn and then n minus 1 d, and then the other side would be minus m squared. Now if I add these two equations side by side, as you see, this term will cancel that term, and then if you see here, this d and this factor of 1 over 2 mn is in common. So let me factor this out when writing. So I will factor 1 over 2 mn from the left hand side and d from the right hand side. Let me make it a little bit bigger. Okay, and then what happens here, I factored this out and I factored d out, so what is left for me is m minus 1. And then I have a minus sign. This is factored out, this is factored out, so what is left for me is this one. Okay, on the right hand side I have n squared minus m squared when added together, yes? But let me open this up, it becomes m minus 1, I multiply the negative sign in, it becomes negative n plus 1, this one and that one are gone, so it becomes m minus n. So I will get this relation, so I will get 1 over 2 mn, and then I will have m minus n times d. On the right hand side you immediately recognize the conjugate pattern, but because here m appears first, I will factor a negative sign out first, then it becomes m squared minus n squared, then I will factor it factorize it using the conjugate pattern, so it becomes m minus m plus n. Yes, so this is the expression that I will transfer here. So this becomes minus m minus n times m plus n. But it is mentioned in the problem that m and n are distinct natural numbers, so this guarantees that m minus n is not equal to 0. So I can safely divide both sides by this m minus n, so m minus n is gone from both sides. So what is left for me is 1 over 2 mn times d is equal to minus m plus n. And then I am looking for d, so I multiply both sides by 2 and I divide both sides by m times n. So what I will get simultaneously, if I do these operations simultaneously, I will get minus 2 times m plus n divided by m times n. Okay, so this is my d in terms of actually m and n. Now I need to replace, for example, I need to go to one of these equations, either here or there, and just replace d with this expression. Then this becomes an equation in terms of a1, and I can solve and find a1. Of course, there are some algebra going on, but these are elementary, I would call them. Okay, so what we can do, we can write m a1, okay, plus 1 over 2 m times m minus 1, and instead of d now I put this expression that I got, minus 2 times m plus n divided by m times n, and then on the right hand side you will have n. Okay, and then what you see, this m in the denominator will cancel that m, and these 2, minus 2 and 2 are cancelled, so what is left for me here is a negative 1. Okay, so it becomes MA1, so let me start from here. So it becomes MA1, and then I will have a negative sign, yes, m minus 1 times m plus n divided by n. And on the right hand side I will have n. Yes? Double check. Yes, everything is okay. Now I am looking for a1, so it motivates me to move this term to the right, and then finally I am supposed to divide by am. Yes, so ma1, so let me just do it in 2 steps. So it becomes n plus m minus 1 m plus n divided by n. And then if I take the common denominator, might be it is better, so let me calculate this, the common denominator between this term and that term, because the denominator here is 1, so the common denominator between these two is just n multiplied by n is n squared, and then plus, I have to repeat this expression here, but instead of repeating it, let me just expand that, so it becomes m squared plus mn minus m minus n. And finally, because I want to find a1, so I divide both sides by m, so a1 becomes n squared plus m squared plus mn minus m minus n divided by m times n. Yes, so that is also a1. Okay, so now the tedious part is left. So I am supposed to calculate this expression. Okay, but remember, this is s sub m plus n. So this m plus n is playing the role of this index k. So if I want to write a formula for this, I have to replace k everywhere with m plus n. Okay, so let us just do that, and I will write this expression. Okay, so the question mark here is m plus n plus s sub m plus n. So I repeat m plus n, but instead of s sub m plus n, let me make it a smaller here for you. So I am just replacing this k with m plus n. Okay, so it becomes m plus n divided by 2, and then I will have 2 times a1 plus m plus n minus 1 times d. Okay, now let me make it the size, the normal size. Okay, so now we have to simplify this expression. On the one hand, I know this is d, on the other hand, I know a1 is that. Okay, but before doing that, because you see that m plus n appears here and there, so let me factor m plus n out. But I would prefer to factor m plus n divided by 2 out, even though there is no 2 here. So what can I do? I factor m plus n divided by 2. The first one doesn't have 2, so it becomes 2. Yes, you see, if I multiply this back by 2, 2 and 2 are cancelled, so m plus n is left, which is exactly this term. And then the other one is 2a1, and then plus m plus n minus 1 times d. Yes? So that expression that I have written here is exactly the whole expression. Now it's the time. I replace a1 with this expression, and I replace d with this expression. So this becomes m plus n over 2. Then I have 2 plus 2 times a1. So what happens here? It becomes 2 over mn times n squared plus m squared plus mn minus m minus n. And then I will have the other expression, which is m plus n minus 1 divided by m over n multiplied by minus 2m plus n. Yes, so what I have done here, so you see this 2 is this 2. in A1 I have a denominator m over n, I have written it here, and then I have the whole expression in the numerator that I have written it here. And then when it comes to the next one, m plus n minus 1 is exactly this expression, and I have chosen to put m over n in the denominator of this, and then I have repeated this part here. The reason that I wanted to do this because I also want to factor this mn out, 1 over mn out. So what happens, it becomes, of course these are not mandatory things, you can just do it according to your taste. Okay, so I'm just factoring mn out. So what is left from the first term, it becomes 2mn. Why? Because now if I multiply this mn back here, this mn and this mn are cancelled, so I have a 2 here, which is exactly the first term. But I have pulled this out, so 2 is left and this expression is left. So I will multiply these 2 in that expression. So it becomes 2n squared plus 2m squared plus 2mn minus 2m minus 2n. Okay? And here what I have done, I have pulled mn out, so what is left for me, m minus 2 is left, and this one and that one. So let me just do it in 2 steps. I put minus 2 here, and I start multiplying this by that expression. Okay? So what can I do? It becomes m squared plus mn plus nm plus n squared minus m minus n. Yes? Now, can I simplify things a little bit? Yes. So I have m plus n here divided by 2mn. So you see here that I have a 2mn here and a 2mn here, so it becomes 4mn. And then I have to repeat the other things because there are no similar terms involved there. But then I have a minus 2 to multiply inside the brackets. Yes, so it becomes minus 2m squared. And look here, I have mn plus mn, which is 2mn. When I multiply it by minus 2, it becomes minus 4mn. And the next one is minus 2n squared plus 2m plus 2n. And now let us see how it goes. Minus 4nn, this one cancelled. Minus 2n squared, 2n squared. Minus 2m squared, 2m squared. Positive 2m minus 2m. Positive 2n minus 2n. So everything is gone. So what you get is m plus n over 2mn times 0. And that is exactly 0. So this means that my question mark m plus n plus s sub m plus n is equal to 0. Okay? Okay, now let us solve this problem in a different way. I really recommend you, if you want to learn mathematics, it's really important to try to solve one single problem from different perspectives. It's really instructive if you want to make progress in learning mathematics. Okay, so let us try to see this problem in a different way. Here it's mentioned that m and n are distinct natural numbers, so it means that either m is greater than n or the other way around. And this problem is completely symmetric under any interchange between m and n. Yes, if I change m to n, n to m, the problem doesn't change at all. So without loss of generality, I can assume that n is greater than m. Yes, if you don't like this way, you can just, of course, solve this problem assuming that n is greater than m, and once solve the problem assuming that m is greater than n. But what I want you to understand, there is no need for the second one because this problem is just completely symmetric with respect to n and m. Okay? So here I would say that without loss of generality, I suppose that n is greater than m. Okay, now if I ask you what is the meaning of s sub m plus n, it means that you have to add the terms of this arithmetic progression from the first term up to the m plus nth term. Yes, so it means that you start adding terms, the first term, a1, and then you a2, and then you continue. At some point you reach to mth term, but because m is smaller than n, we are assuming that m is smaller than n, first you reach to the mth term, and then if you continue, it means that you go to the next term, which is m plus first term, and then you continue. At some point you reach to the nth term, and then you continue. The next term is n plus 1, and then finally you continue until you reach to n plus m. Yes, and this is the sum. This is the meaning of this symbol. But of course, now if I ask you, do you know this sum? You would answer yes, because this is the sum from the first term to the nth term, and that is exactly equal to s sub m. But s sub m is given in the problem itself, which is n. Yes? Now, if I ask you what is from here to here, this is exactly from the first term, the sum of the first up to the nth term, and that is s sub n, which is given to be m. Yes? And then something becomes clear, because you are adding more terms and you are getting m, and I am assuming m is smaller than n, so definitely it is clear that the common difference here should be negative. Okay? Now, these are the things that I am just thinking loudly. Okay, so if I ask you what is the sum of these terms, you can answer that. Let me change my color here. So if I ask you what is the sum here, you would say this is m minus n. Yes? This is the sum of the terms of these middle terms. But what I want to make sure that you know is what is the relation between this bit and this last bit. Okay? First of all, how many terms are involved here? There are m terms. And how many terms are involved here? There are exactly m terms, from the n plus first term to n plus mth term. Yes? So the number of terms are the same. But there is a very nice property of arithmetic progression. The arithmetic progression, so let me write it here with my different color. If m, n, p, and q are natural numbers such that m plus n is equal to p plus q, then for any arithmetic progression you can write a sub m plus a sub n is equal to a sub p plus a sub q. Okay, so that's a very nice property of arithmetic progression, and let me prove it here for you if you don't know this property. Okay, so hopefully you remember this property from your previous studies, that a sub k is equal to a1 plus k minus 1 times d. So that's a famous relation in arithmetic progressions. Okay, so my goal is to prove this equality under this condition. So I start from the left hand side and I continue to reach to the right hand side. Okay, so let me write with a different color. So this is not part of the solution actually. So the left hand side is a sub m. It means that I replace k with m, so it becomes a sub 1 plus m minus 1 times d plus a sub 1 plus, instead of a sub n, I write a sub 1 plus n minus 1 d. Yes? Now what happens, I can write it as a1, so it becomes 2a1, and then here between these two terms I factor a d out, so it becomes m plus n minus 2d. Yes, do you agree? If I pull this d out, n minus 1 is left from here, n minus 1 is left from here. When I add them, it becomes n plus n, and then minus 1 becomes minus 2. But now, according to this condition, we know that n plus n is exactly equal to p plus q. So if I continue, this becomes 2a1 plus p plus q minus 2d. Yes, and now I can decompose it. Yes, I can write it as a1 plus p minus 1d plus another a1, this time q minus 1d. Yes, it is very easy to convince yourself that what I have written here is a decomposition of this expression. a1 plus a1 is 2a1, and if I add these two expressions, I will get the same thing. But now if I ask you what is this, you can immediately compare it with this one. You see that everything is the same except that k has been replaced with p, so this is a k, so this becomes a sub p. So this becomes a sub p plus the other one for the same reason is a sub q, and that is the right hand side. So that is the proof of my claim here. And by the way, this is an extremely important relation when you deal with arithmetic progression. It's good to know about that. So now let us make this a little bit smaller so that you can see. Here, what I want to say is, if I take this index from 1, so let me just repeat what does it mean. It means that if between these indices this relation holds, this relation also holds for the terms themselves. Yes? So here, now look here. 1 plus n plus m, what is that one? So you see here, let me write this now. 1, this index of the very first term, plus that index n plus m, okay, is equal to. The next index here is 2. The previous index here is a n plus m minus 1. Now 2 plus that one also gives me this, you see, 2 plus n plus m minus 1. Do you agree? Because this sum is exactly this sum. And let us go to the next one. The next one from the first is a sub 3, and the previous to the previous one is a n plus m minus 2. Now if I add this index with that index, what happens? It becomes 3 plus n plus m minus 2. You see, these equalities are all correct. They are the same thing. I continue the same way. This last term here with the very first term here. Again, this is quite clear that they are the same. M plus n minus 1. Okay, so hopefully what I have written is clear. If I ask you what is this, you simply say it's n plus m plus 1. If I ask what is this, minus 1 and 2, it becomes 1, so it becomes n plus m plus 1. Again, what is this? N plus m plus 1. So you see that what I have written here, even the last one is m plus n plus 1. So everything is equal. So according to this rule, what can I write? I can write a1 plus a sub n plus m is equal to a2 plus a sub n plus m minus 1 is equal to a sub 3 plus a n plus m minus 2, and this continues until I have a sub m plus a sub n plus 1. So all of these sums are the same. Okay? So now if I ask you what happens if I add this one to that one, I can write them in pairs. Yes? So let me write this for you. S m plus n is equal to. This part I don't have any problem with that. It is m minus n. So let me write that bit first. Okay? Then instead of adding these consecutively and then adding them, I reorder them and regroup them. I add this one to the last one. It doesn't matter, yes? So it becomes a1 plus an plus m. Then I add this one to the previous one. So it becomes a2 plus an plus m minus 1. And I continue this process until I add this one to this one, yes? Okay, so this is Sm plus n, but we learned that all of these pairs are exactly the same. So instead of writing this, I can write the same expression and I can continue on. Instead of writing this, I can write the same expression. So in principle, this becomes m minus n plus a1 plus a sub n plus m. The next one is also a1 plus a n plus m. And then until the very last, this is again a1 plus a n plus m. Yes? So then you see that I have the same expression added to itself. How many times? M times. Yes? So this is m times. M summands. So all of them are the same. So what is the take on? This is S sub n m plus n is equal to m minus n plus m times a1 plus a n plus m. Okay, so this is what I got. Of course, if you are experienced, I explained a lot to make sure that you really understand the details. But if you are experienced in these kinds of calculations, you can skip all of them. So I myself believe that this method is simpler than the previous method, even though you might think that there are many algebras going on. No, I mean that if you are experienced and you have trained quite a lot in this particular case, coming to this conclusion is not hard at all. Okay, so I would prefer this method in compared to the previous method. Okay, but now do you remember we had a formula S sub k? There is another formula for the sum of the kth term. It's k over 2 and then the first term plus the kth term. Yes? So this is just again the same formula for S sub k, yes? Okay, so instead of this one, what can I write? I can write m plus n divided by 2. Okay, so I have replaced this k and this k with m plus n. So then it becomes a sub 1 plus a sub m plus n equals to m minus n plus m a1 plus a sub n plus m. Okay? And now you see that in principle I can calculate this part. So I move this to the left hand side and I pull this, I factor this out. So what is left for me? So it becomes m plus n over 2 minus m multiplied by a1 plus a sub n plus m, and then on the right hand side m minus n is left. Okay, so now you can simplify this. How? Instead of m you can write 2m, you can write 2m over 2, but you have a minus, so m plus n minus 2m is n minus m. So it becomes n minus m divided by 2 times a1 plus a n plus m equals to, let me factor a minus sign from the other expression, so it becomes m minus n. The reason that I did it, because I want to divide both sides. Oh, I don't, I made a mistake here, sorry, I have to replace n and m. When I factor the negative sign out, they are being replaced. So now you see that this term and that term is cancelled, and I multiply both sides by 2. What I get is a1 plus a n plus m is minus 2. Okay? Now let me give this a name number 1, and let me give this a name number 2. Okay, now let us compare number 1 and number 2. So let me write a little bit smaller. So from number 1 and number 2, what I can conclude, S sub m plus n is equal to m minus n minus 2m. Do you agree? Instead of this expression, I put minus 2, so it becomes minus 2m. But what is this? This is just minus m minus n. Agree? So, and then I move these two to the right. They both become positive. So it becomes m plus n plus s sub m plus n is equal to 0. The same relation. Yes? Okay. I hope that this video was useful for you and you enjoyed solving this problem. Below this video you will see the link to the PDF file of this solution. Until the next video, be safe and goodbye. Okay, now let us look at this problem even in another way. Okay, so I want to use this formula once more and a result that I got from the first solution. So I would say that I will come up to here, up to this point. Okay, so this is probably the simplest possible way to solve this problem. So you remember that we just talked about this formula. S sub k is equal to k over 2 a sub 1 plus a sub k. Yes, this is the general formula for the sum of the first k terms in an arithmetic progression. Okay, so now let us write the formula for s sub m plus n. So what is s sub m plus n? This is equal to m plus n over 2. Instead of k, I have m plus n multiplied by a plus a m plus n. Yes? But I can decompose it into two parts. Sm over 2 multiplied by this. Yes? And plus n over 2 multiplied by that. Okay? But now let us see what is this expression. I can write this expression in two different ways. Here I can write a sub m plus n. I can consider this term n terms after the mth term. Yes, so this means that this is the mth term plus n times the common difference. On the other hand, a sub m plus n can be interpreted exactly the same thing, yes, because m plus n and n plus m are the same. So here I can consider the same expression as m terms after the nth term. So this means that this, on the other hand, can be written as an plus m times d. Okay, so now I will take this one and put it here. Okay, and I will take this one and put it here. They are the same thing. Okay, so then it becomes s sub m plus n is equal to m over 2. I have a1 plus a sub m plus nd, and then I have m n over 2 a sub 1 plus a sub n plus md. Now what I do, I will take m over 2 and multiply it by this combination of these two and then multiply it here. I will multiply n over 2 by the combination of these two and then here. So then it becomes m over 2 a sub 1 plus a sub m plus 1 over 2 m n d. The other one is n over 2 a1 plus an. Then it becomes 1 over 2 n times m times d. But now if I ask you what is this expression, you see this is exactly the same expression unless k has been replaced by m. So this is nothing except s sub m. And the same story here, this is s sub n. And then instead of this one and that one, I add them together, it becomes m and d. But I can continue further, yes, because in this problem s sub m is given to be n, s sub n is given to be m. So this becomes n plus m plus m n d. Yes? But now do you remember we calculated d in the first solution, in the first method. So let me just use that information. So this is the expression that I have to take with me to the other page. So it becomes minus 2 times m plus n divided by mn. Yes, but now what happens? This mn and that mn are cancelled. and then I multiply that, so it becomes n plus m minus 2m minus 2n, which becomes minus m minus n. So I realize that s sub m plus n is this expression, so I move everything to the right, so it becomes m plus n plus s sub m plus n equals to 0. So probably this is the best solution for this problem. Yes, so it's a combination of the first problem and a very different point of view, not a very different point of view, a different point of view of how to look at the geometry arithmetic sequence here. Okay, I hope that this video was useful for you. Below this video you will find the link to the PDF file of these solutions. Until the next video, be safe.